Soaps are unquestionably essential to maintaining our hygiene. Contrary to popular belief, soaps do not kill germs, but instead they act as an emulsifying agent. It surrounds them and carries them when washed away with running water. It is because of its unique hydrophobic head and hydrophilic tail that allows soaps to do this. Besides washing away germs, it can also wash away oil and fatty substances. On the other hand, soap also has its disadvantages. After we wash our hands, most of the soap that we use will leave the drainage and will end up in the environment. If the waste is not properly treated and disposed of, it may end up in our groundwater and contaminate the environment. Antibacterial soaps may be able to kill all the bacteria in our hands, but in the long term, this may lead to the development of highly resistant bacteria. The main chemical reaction in making most, if not all soaps, is saponification, which is the hydrolysis of ester with an alkali base such as sodium hydroxide or potassium hydroxide. The alkali base will affect the texture of the soap, while the fat will affect its triglyceride composition. There are two ways to make soap: the more modern cold process or the more traditional hot process. Our purpose for the experiment is to determine how the change in the amount of olive oil will affect the soap formed. The independent variable in the lab is the amount of olive oil added, while the dependent variable is the amount of soap produced. The control variables are the amount of sodium hydroxide and the amount of water added. If the amount of olive oil added is increased, then the amount of soap produced will also increase because there will be a greater reaction. The materials that we used in this experiment include 130 milliliters of olive oil, 15 grams of sodium hydroxide pellets, and 45 milliliters of distilled water to make your lye solution, 6 beakers, 1 graduated cylinder to measure out your olive oil, 1 thermometer to measure the temperature of your lye solution, 1 piece of paper to mass out your sodium hydroxide, 1 tweezer to carry your sodium hydroxide, 1 scale to mass them out, 1 stirring rod to mix the solutions together, and 3 goggles for protection. First of all, 5 grams of sodium hydroxide was measured out with the scale. Next, the sodium hydroxide already massed out was poured into a beaker which contained 15 milliliters of distilled water. For the first trial, 28.35 milliliters of olive oil was measured out using the graduated cylinder. As you can see, the sodium hydroxide has dissolved in the water, and this is the lye solution. Next, the lye solution was poured into the olive oil and was mixed with the stirring rod. After mixing, the soap is set out to dry for 24 hours.